Hey guys, quick test. Can you hear me at home? You can type in the chat if if you can hear me, just confirm that
Yeah,
you can hear me.
we can hear you.
Okay. Okay, so I've gotten a little better at this online thing now that I do have the chat open at all times, unlike before where I wasn't able to check on it, so I can just see it right away. So if those of you who prefer to just text instead of saying out loud in the room, you're more than welcome to just type in the chat, or even if you have a question, and especially when I have a question and I'm asking like the group something and you want to answer, you can also write down in the chat your answers, okay? So we're gonna get started pretty soon. Now, in the last lecture, we were talking about architecture, and architecture is the very first phase of the software design or the solution domain, if you recall. And with it, we get the maximum amount of flexibility, but also the maximum amount of responsibility as well, because we are starting off with a complete white page. All right. Now, luckily, we do have some help because a lot of the problems that exist in the world have a lot of similarities. Even if the domains themselves are completely different, they still have a lot of similarities. So like I said before, if you are building a system that really requires some sort of a geographically separate locations with a client and a server, and you're gonna need a network connection, whether it's you're using it to book hotel rooms, whether you're using it to book car rentals, whether you're using it to register in your classes, they're still ultimately, from a generic point of view, the same problem, and they require the same architecture. All right. So what we're going to be doing today, and is that we're going to capitalize on the fact that a lot of these problems are so much similar to each other that the people in the software world have created high-level solutions that are similar to each other as well. So, once you find a concrete problem, the hardest part is to realize that this problem is part of or similar to an abstract problem, and you try to apply an abstract solution with it. Okay, we call this an architectural pattern, and at the lower level we call this design pattern. And with it, you start to apply your architecture to get a concrete solution. So we're going to take a look at some of these architectures. The first of which is a data flow architecture. All right. And data flow architecture is very much like the concept here is the data itself, which is our main raw ingredient, and we are tracing how this data is transformed from one process to the next to the next. So every process takes in that data, does something with it, then it moves it on to the next process, which means that the output of one process is the input of the next process. And this is a main frame of thinking, all right, which is kind of like different than what we've been used to in, say, SE100, where it was a control-based paradigm. So you have your main function calling out other sub-functions, and the other sub-function calling out other sub-functions, and then they return back to the main function, okay? So the data flow architecture is as such. In the unified modeling language, UML, it doesn't actually have a diagram for that. But in situations where your process is mainly driven by the data, okay, so you're feeding in like in an orange juice factory, okay, the main thing is the oranges, okay, so you get the oranges as they come from the truck, and then what happens with the first machine, and then the output of the first machine is the input of the next machine, and so on and so forth, until the last machine packages it up to trucks to take them back again to the supermarkets. All right, so if this is the case, if your main driver of your application is the data itself, then you want to use a data flow architecture to pan out the architecture of your application. All right, so a very, very practical situation of this, a lot of times you see payroll. Okay, so payroll, you grab a lot of information about employees, the hours that they put in and so on. And then it goes through different processes, and every process, its output is the input of the next process, until finally your actual pay is calculated and a pay stub is produced. And then finally, a deposit is made into your bank account. Okay. Another example of this is when you see, for example, those applications that transform a Word document to a PDF. Okay. So it's not about the process itself, but rather the data itself, that somehow it changed from a Word file to a PDF, and then maybe from a PDF to a picture, and a picture to something else, and so on and so forth. So it's not the focus is the process, but rather the data and how it got transformed from one process to the next. All right. It's called sometimes a pipe and filter. And in Unix, those of you who use Unix, it's very common that you have a lot of these filters or these processes lined up, and then you give it the input, say, for example, a particular file, and then it executes those processes one after the other sequentially, sometimes if it's a really sophisticated application, then it could be done in a concurrent situation as well. All right. Next up is the independent component architecture, which is very, very complicated way of just saying client server architecture. Okay. Now, client server architecture, I'm pretty sure you've actually heard of that, which is what the internet is all based on. And because it is such a key role in the world that we live in, okay, it will be a focus of an entirely separate chapter in this course, which is the next chapter. So I'm going to skip this for now, and we're going to come back and visit it at the beginning of next chapter. Okay, so that's all the internet client server. You know, you're using something on your phone, which is in some data center and some server is sitting in the United States, and you're getting back the service back. All of this is called independent component, meaning that your phone is independent from the actual server that you've just used in the United States. They don't need you to live. You don't need them to live. In case you've been disconnected for the rest of your life, you'll still be alive. Okay, your phone will still work, their servers will still work. And this is where the word independent component comes in. But like I said, it's really just a fancy way of just saying a client server architecture. Did you have an interview or something? Yeah, okay, that's why the suit, huh? Every time you see somebody with a suit, you're like, yeah, I just came back from an interview. So I just called you out. All right, anyway. So next up, we have something called the virtual machine architecture. Now, a lot of the time, what we do in our applications is that we create codes of codes. Funny enough, right? And the point is, if we just go to the ultimate low-level coding, it just gets a lot more complicated to write in it, to use in it, okay? The first example that I'm going to give about this, a lot of times you see people who are doing, people say in the travel industry, okay? And somebody who's reserving a ticket. Now, when you get to reserve a ticket, we tend to use our, you know, user-friendly GUI platforms, whether it's an app or so on, and something we do. But ever go to a tourism office, okay, ticket reservation, they're always like typing frantically on their keyboards, okay, to book a ticket for you. And you're like wondering, well, what sort of system are they using? Okay, they must be using something else. Obviously, the system that they're using has a lot more authority than yours, has a lot more sophisticated capabilities than yours. So they can do quite sophisticated searches that would take you 100 clicks and maybe 50 minutes to complete if you do it on a web-based form or just your app, okay? So they can say, check for all the available flights from here to Jeddah over the next month on Tuesdays and Wednesdays and Fridays from 6 p.m. to 12 p.m. That much of a sophisticated search all in one line, okay? Now what they do is they write keywords, okay? Now those keywords are then translated into something similar to the 100 clicks that we would have had to do had we just done a GUI approach, just a regular plain one search at a time. But that's what their virtual machine is doing, okay? It's reading those codes and translating it into bigger code. Now, what exactly is happening here is that there's something called an interpreter, okay? It's a little program that we train to say, once you see this, translate this into something else. So you see that line of code, but then once you see it, translate it into 5 lines of code to do something more sophisticated. All right, and this is how the travel industry works, and this is why they're doing all these massive searches, all of them with some sophisticated keystrokes, and then they're done. Okay, another example related more to the software world. Okay, you get to see, for example, Java, okay, or Python. Okay, when you write down x equals x plus 1, don't think that the computer just reads it and then immediately realize, okay, well, I'm just going to execute that line as is and we're done. Actually, what happens is that x equals x plus 1 is then translated into a whole bunch of assembly language code. Okay, because computers actually don't work with adding. Okay, what it actually does and what computers do is that they have registers. You might have heard this term before. They have a CPU. There's a CPU that's registered in those CPUs. Register a little piece of memory that exists within the processors, and it keeps shifting numbers around. And how it shifts the numbers around, it actually then does and performs the addition. Okay, so this x equals x plus 1, which we do in our brains immediately in one shot. Okay, the computer has to translate that first into assembly language code. Move AX, BX, AX is a register and BX is a different register, which is then later on translated to zeros and ones. Okay, you know what those zeros and ones are? Okay, those zeros and ones are little instructions at the processor level to say, move this little piece of data from here to there, move that little piece of data from here to this, and so on, in order to do the calculation for it. Then it comes back again all the way up to the output, and then you get to see the nice x equals x plus 1. Then now the value of x has been incremented by 1. Okay, how do we ask you to do all of this by writing zeros and ones? Nobody would be programming in this world. All right, now with Java comes something called the Java interpreter. Okay, comes something called Java interpreter, which we train and see. And when it looks at, say, something like x equals x plus 1, it knows, all right, that I have to transform into something completely different. Okay, and again, this is where the virtual machine architecture comes into play. All right. Next up is the repository architecture. Now, the moment I say repository, everybody thinks database. All right, let's just get this one thing straight out of the water here, is that database is nothing but a very sophisticated flash drive that you have in your pockets. Okay, you know, it's just a memory thing. It doesn't do much thinking. All it does, it can, you know, perform searches quite fast. Okay, does some filtering, does some rational reasoning, like this number is bigger than that number, or this number is equal to this number, and that's it. Okay, that's what databases are. Okay, it's not an architecture in itself. Okay, it's nothing but a piece of memory, very large one and a very fast one at that, and that's it. Okay, what? Oh, you have a question. Repository. Yeah, the repository is a place where you store all the information, and this is why I am like putting out the disclaimer to avoid all this confusion. It's like, okay, I know the repository architecture, that means database. No, it doesn't mean database. Okay, now the repository architecture basically says that everything, and I know it doesn't help that it says database in the middle here, but just ignore it for now and just think of repository. That if I have different application 1, 2, 3, 4, 5, they're all using a variable called X. Okay, instead of each one of those processes, applications, apps, doesn't matter what you think of them, have their own version of X, they are actually, there is actually one copy of X, and it's in the repository. Okay, yes, that X could be stored in a database, it could be stored in a flash drive, could be stored on a file. I'm sure you've done some reading and writing from files, right? it could just actually be stored in the local memory, like within a Java virtual machine. They're all the same X. Now, what that means? Hmm? No, 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 no. It's the same X, the same value, one copy, and that's it. So here it is. This is the X, and we're all looking at the actual same thing. Okay, which means if app3 over here comes and changes X, okay, everybody else is going to see that change immediately on the spot. There is absolutely no chance for a consistency, which is a big, very good plus for repository architecture, right? That everyone over here gets to see the same thing. And this is why when you book a ticket for your phone and then 1 minute later, you open up your laptop and log into the same website, you can see your ticket reserved over there. Why? Because it's stored in a repository. The repository architecture, yes. No, that's a race thing, okay? Now that the race thing has been resolved and you bought it, okay? So let's just say you bought it. Now, between your account on the phone and from a laptop, which is two different processes running at the same time, okay? But they're seeing the same thing, okay? Why? Because it's actually the one thing. There's only one ticket and it's in one place, all right? So that's why it doesn't matter what type of phone you're gonna look with, what type of processor you're gonna use, because this one is always gonna be consistent. And a lot of web-based systems, they do that, okay? Now, you might wanna have a backup, which is just putting on the side, not being active for the purposes of disaster recovery, and that's a very good practice. But that doesn't mean you are using multiple versions of the data, okay? So it's a shared repository, shared data between everybody, all right? Another thing about differences between databases and repository. So repository is a concept. You can actually, like I said, use a file, use local memory, use a flash drive, use a database, using even multiple database, which is what happens in reality. You think, for example, Facebook or Twitter have one database. There's like a million tweets being tweeted like every second. You think all of that is going to be stored in one database? It's going to be hundreds and hundreds and thousands of mega of those databases, okay? But still, that tweet is in one place and one place only, at least one active place. Like I said, there might be backups, but they're not really active, okay? And those backups tend to back up, like say once every 6 hours or once every 12 hours, depending how you set it up, okay? Just for the sake of disaster recovery, like, you know, ultimately, that data that you have is stored in a place that is actually physical at the end of the day. And let's just say a bomb just falls off on that place and destroys it. No, that data is gone. So you want to have a backup. And naturally, when it comes to data recovery process, it's a good practice to have it in a different city completely, in case the entire city shuts down. Okay. So in a company that I used to work in the stock exchange, we used to work in New York, but their disaster recovery offices were all in Chicago for that purpose, okay? So it does come with the advantage of having consistent data across the board. Another great advantage is that had I had large amount of data that is actually being shared between the different applications, it's just easier to put them in the middle and everybody access. Okay? Now, if we didn't have that repository, okay, that means that this large amount of data to be shared, this guy has to have a full copy of it. This guy has to have a full copy of it. This guy has to have a full copy of it, okay, which is what happens nowadays with the blockchain architecture. You've heard of this term, okay? If you haven't heard, don't worry about it. It's not part of this course yet. And this guy has to share this large amount of data with this person. This person has to share a large amount of data and that person has to share a large amount of data with app number 2 and so on. So it's a lot of information going back and forth and back and forth and back and forth. And then app 2 changes this piece of information. Uh-oh, we got to go all over again, telling everybody, oh, okay, let me share this with you. Let me share that with you. So the amount of data going back and forth is just absolutely astronomical. It's a lot less had we had it in one place and one place only in the middle. Okay, if you have an IDE tool like the ones you're using to build your code, okay, so there's a lot of action processes running that are looking at the code. So you have the repository in the middle, then you have, you have the thing that actually shows the code, lexical analyzers, you have things that creates models for it, XML, all of them, they're all thinking and they're all looking at one piece of information, which is the text that you've written, and they're all using it. You don't want each one of these processes to have its own version. Inconsistency start to happen, and then now you run something which is different from what you're seeing in front of you on the screen. Okay. So like I said, its advantages, it's an efficient way to share a large amount of data. We don't need to be concerned about how data is produced. Me as a process, I worry about the function rather than data. We have a centralized management system being backup, security, okay? It's over here, okay? It's done in one place. I can put all my focus over there. I don't have to repeat this effort here, and there, okay? Now, the good thing is it does save me that effort, but also it does raise the issue of there being a single point of failure. And hence we have those backups and so on, okay? And also being a single point of failure also means that I can also focus all my attacks on this one. But then since you know this is the only place you have it, then you would fortify this place to the extreme. Whereas have you had the data in different places, it's a double-edged sword, okay? Your weakest link is how strong you are, okay? So if this is the weakest, I'll probably just attack this one, and the information I get from this one is as equal to the other apps as well. Now, one of its disadvantages is that those subsystems have to agree on a schema. Now, in sense, a schema is a format of data, okay? It has a lot of meanings, but just to simplify it, okay? So, for example, here I am, I want to store age. I like to store it as a float, all right? And we got the app here likes to store it as a double. We got Anim here, she wants to store it as an integer. Ultimately, there's only one version of it. So we're gonna all have to agree on a compromise. One and only, okay? One of us may be happy, the other two will be not so happy, okay? So the fact that you have to compromise is a disadvantage. The other thing is that data evolution is difficult. So finally that we've done the compromise, okay, and we set up the format in a certain way, okay, first name first, then the last name. Every 500 of those applications that the first name is first and the last name is last, and then we decide to switch. So the last name is first and the first name is last. What you got to do now is go back to all 500 and tell them, oh, we've changed. Can you please make sure that you update your process as such? Which is what happens, for example, when like Adobe Flash comes up with a new version, then you have to like re-download, or even any of your apps now, when it makes a change, what you have to do is you have to go back and download the new version of it so that it updates with the new information and so on and so forth, okay? And there's a part where there's a responsibility for you, okay? Now that's okay when everybody's got their own phones and each version of the downloaded app is controlled by one person's job to do it. But imagine something like a university setting like we're here, and there's 500 computers that belong to the university, not to a person, but just a university. And these are different 500 processes that I have to update in case I do change my data or change something in my process. Now, it could be data, it could be some sort of a function, even that could be updated. So I have to, literally what it used to be, you'll see the IT person sitting on the first computer doing an update, and they get up, go on a second computer, do an update, and get up and do the third computer. And it's just a very tedious job. Yes, you had a question.
So you can't change the three apps individually?
You are actually doing that.
Then you can change it from the repository from the very beginning.
No, okay. I'm not sure if I understand your question, Fred, but when we got together, first time,
I want to make a change.
you want to make a change, but what stage are we on? Okay, so at first, when we didn't have the repository and we wanted to build it, we had to agree on a compromise. Okay, so because we can't have it float double and integer at the same time, we got to agree on one. But now that we've agreed on it, okay, and I decided to go with integer, the least accurate one, and then I decided to go, no, I'm gonna go double. I have to go tell app3 now it's a double. I have to go tell app1 now it's a double. App2 is double, and it's a tedious job at that.
Yeah, but after this.
Once you're done, you finish, you finish.
Some values or something.
No, the value itself is okay. The format of the values that it's not okay. No, I'm saying here data evolution and the schema itself is what's difficult. All right, but x equals 5 got changed. That's gonna stay here until one of those apps wants to read it. All right, but it will be the same. That's the most advantageous aspect of a repository.
So is the repository always for one aspect, or it can be for more than one? Like, if I want to make a repository for the numbers, I have to make one, and then for the values, you make another one, or it can be a one system that contains all the other values.
I'm not sure. You have data, okay, but basically the point is that x, the variable x, instead of app1 and app2 and app3 have their own versions of x, which at some point means that app3 could have x equals 4 and app2 have x equals 3. That doesn't exist. We only have it in one place. It's in the middle, and everybody's looking in the middle to see that. Okay, like another example of this is Google Docs. Okay, so back in the day, when you were working on a project with your friends, right, you had to have that in one place, and then everybody's working asynchronously, and then you get together and you hope that you've gotten the most updated version. Now with Google Docs, that document is actually in Google, and when you're editing in Google, and so Diab is looking in Google at the same exact place, at the same exact location, so much so that when you're changing and he's changing, he's actually seeing what you're doing real time. That's really the whole point behind, okay? So it comes with the advantage of consistency. That's excellent, okay? Consistency. And also the advantage of, in case you want to share a large amount of data, I mean, imagine that document that you had is 3,000 pages long. Try emailing this and emailing to all your buddies and all. It's just a pain, right? Rather than just having one place, it's almost like a Dropbox link and saying, download it from there, okay? So that's the advantages. Now, at some point, architecture, you'll realize there's a lot of inverse proportionality between the repository architecture and the client server architecture, and it tends to be that the advantage of one is a disadvantage of the other one and vice versa, but we'll get to that in the next chapter. For now, we're talking about the next architecture, which is called the layered architecture. And in the layer architecture, basically the premise is that the system is divided into layers, and we have, say, layer 0, layer 1, layer 2, and layer 0 is the bottommost layer. All right. The premise here is that the bottommost layer doesn't need the layers above. All right. And a layer like layer 1 doesn't need what's above it. It only needs what's underneath it. Okay. Layer 2 needs layer 1, which by definition means it needs layer 0 as well. All right. Now, I'm going to give you 3 things. Okay. Something, a concept of a presentation, just the way something looks. And then a process, a function to be performed, like say, addition, okay, and then finally data, okay, just a number, okay. So data would be layer 0 because data is there's no such thing as data needs something. No, data is just data. So x equals 5. 5 is a number. 5 is never going to need anyone. No. Layer 1 would be what? The actual process. Okay. So in order to add 2 numbers together, you got to give me the data, because I can't just add thin air to each other. Okay. Now, adding numbers, I don't really care about presentation. I don't really care about colors, or is it going to be in a table? Is it going to be flashy? Is it going to be red, green, blue, underline? I don't really care about this. I'm just, from a mathematical point of view, from a functional point of view, I just need the data. Okay, and then finally, the presentation, which uses the results of this functionality being performed, unless it's just showing the data as is from layer 0, but it's usually just showing the results of the functionality being performed. Okay, it then shows it in a table, with all these fancy sorting mechanisms, with the highlighting, and maybe one row gray, one row white, one row gray, and keeps alternating. And we do all these fancy looking things, bootstrap and the like, everything that your heart desires, but it requires that the data is here and the functionality has been performed. So here's another example. We have a football system, or a football league, and you want to see the latest standings. Okay, which team is first, which team is second, third, fourth, and fifth. And at the bottom would be a database just containing all the information. Okay, team A, how many wins, how many losses, how many goals scored, how many goals against, and so on. Just data, just the facts that exist in the world. All right. In the middle would be your Java code that you've been developing since SC100, which reads those arrays of information, starts to do the computation, multiplies each win with 3 points and each draw with 1 point, and so on. Okay, and it does the sorting. Okay, SE was it 214? Does all the sorting stuff. It does all that work, and that work is independent of a presentation. And then finally, it gives it to layer 2 and says, here it is, the information you asked me as raw data. Exactly. You go ahead, present it any way you want. Yeah. All right. Now that layer itself could be divided into even more layers. Okay. For example, one layer could be dealing with the core business units. Another one with authentication. So the authentication comes first. Okay. So the user interface, instead of it hitting the data right, or even hitting the critical assets, it needs to hit the authentication layer first, and then the authentication layer requires that all of this would be available. Just going back again to this slide over here. So when you work in a company, very often you'll see the work split into different teams, and the teams will be split into those 3 processes over here. Now, this over here will be the guys working in the databases, creating all this SQL stuff, PLSQL stuff, and all that fun stuff. And nowadays, there's the document-based databases like Firebase and Mongo, and it makes it a lot easier in case you're storing like documents rather than values. Okay, so this is one group. Next group is the people who are creating the Java code that we've been trained, and with objects and classes and so on. All right. Those people tend to recall, along with the database people, we call those the backend people. Okay, so you'll see somebody on LinkedIn saying, I'm a backend developer. Okay, and then the person at the top here is the one that deals with the with the interfaces, front end developer. Okay, whether it's in web-based or apps and so on. Okay, those are front end developers. Which one of those 3 levels do you think pays most? So layer 0, that's a database layer. Okay, you just got out of an interview, so you should know. Okay, so those are people they create the databases, they design it just like SC. You're doing it right now with Engineer Huda, right? 3.3.12. Okay. I don't know if you've gone to the notations and the min-max stuff. I don't know if you'll get there. It's just fun stuff. Okay, ER diagrams and all that fun stuff. All right. And the triggers between the different. It's a lot of work. I mean, it's not. I'm not trying to belittle or anything like that. Okay, so that's some decent. And then here's the coding that we've been used to all our lives, including the sorting and all that fun stuff. And the top here said the front end dealing with all sorts of GUI stuff, whether it's Swing, very uncommon now, but things like, obviously the web-based with all the HTML, CSS, JavaScript, with all the different frameworks of JavaScript, jQuery, so on. You can just do your hard design backend stuff, no, sorry, not backend, just front end stuff. So which one of those three categories of jobs do you think pays the most? Yeah, of course, it's the most important, but it's not the most difficult. So it's not about the most important, but the most difficult. Now, obviously, you can say something like the front end. You can't say it's not important. They're all important. Now, from a theoretical point of view, it's the most important, as in everything depends on it. Yes, I get it. But when you get people to do the job, right, the easier the job is, usually the less it pays, because there's a lot more people who are willing to do it because it's easier. Okay. Whereas at the top end over here, it's actually the most difficult. All right. And that's why front-end developers get to be paid the most. All right. One of the reasons why this is difficult is because the technology at the front end updates significantly, like say every 2 months. Okay. Whatever you've learned 2 months ago, it's like, oh, you're still using that? That was like 2 months ago. Right. Whereas, for example, Java, has Java evolved? Yes, of course, Java evolved, but the evolution is a lot slower. All right. With all this backward compatibility stuff, come to databases is even less slow. So database and all these things that you're learning now has existed since the 70s. Not much has changed since then. Okay, you get Oracle maybe with, what are you doing? Are you using 11G now? You haven't used it yet? Okay, well, I know it's still week 3, but all it is, it's a graphical user interface to the database design. Okay, not a big deal. But as a concept, it existed a long time ago. Databases existed a long time ago before there was GUI applications. And those have not updated in a long time. Now, okay. So each layer will have a coherent collection of software artifacts. So you're going to have a whole bunch of classes or objects or units in general that obviously heavily related to each other. And each one is using the layer below it. It greatly simplifies the implementation process, because at first, let me just design the data. Let me figure out what is the data that I need. Second, I think of the process that I need. And lastly, I think of the interfaces. And that's a very common way of setting up your system. Okay. And you might have heard of the term EE, not electrical engineering, enterprise editions, like the Java Enterprise Edition programmer. Okay. Enterprise means you're doing this platform, you're using this architecture. Okay. And why? It's because this is the way all enterprises work. Every company that you get to see in the whole world is using this. Okay. There we got a presentation at the top, followed by application in the middle, and data at the bottom. The disadvantage is that sometimes it's not easy to slice them. Okay. So when it comes to the middle layer over here, let's just say within that middle layer, I want to divide it into, say, 2 or 3 functionality layers. Okay. Like subsystem 1 that does the registration, subsystem 2 that does the financing, subsystem. But sometimes you realize that, well, subsystem 1 needs subsystem 2 for something. I realize that subsystem 2 actually needs subsystem 1 for that. So there's a cyclic thing happening. So you can't really put them in a layered architecture kind of thing. So you tend to just shove them all together into one layer. So the slicing of it may not be as easy. Yeah, so that's basically the layered architecture. There's many examples of this. So you have the web browser interface for a system. Then you got the printing manager and the authentication stuff. And then you got the functionality that does the write management, document retrieval, and so on. And then a functionality layer that just sits right above the index of a library, finally by the actual database. And you can see that database 1, database 2, database 3. Does that mean that this is a repository architecture? Not necessarily yes, not necessarily no. Okay, so if I have X and X is here, and there, that's not repository. If I have X and X is just in one of them, then that is repository. What you're saying, can I have more than one database in the system? And again, I'm trying to, as much as I can, dissect between the concept of a repository and the concept of database. Okay, so a database is just a piece of memory. Sometimes that memory has a capacity, and there's only so much you can store. So I'm gonna need more. Okay, but this one will have ABC, and this will have EFG, and so on. That's repository. So the concept of repository by itself, it doesn't lend itself to the term, can we have more than one repository? This is just one. Even if it's split over multiple databases, it's still a repository. Yeah, of course. Yeah. And the repository will have X, Y, and Z, and A, and B, but just the one copy, right? I mean, obviously, not one repository for one value. Okay. All the values that, for example, relate to a project will be there. It's just one version of it. All right. In network design, you see this very, very common. People in computer engineering will see that quite a bit. Okay, so you got the application and the presentation at the top, then you got the session transport and the network stuff. I mean, this is COE stuff. Sorry, computer engineering stuff. I really should just remove that slide. I don't know why I still keep it. Yeah, never mind. All right, so we just talked about this, the presentation layer and the application and database management layer. Okay, the pros that it supports the incremental delivery. I begin from the bottom going all the way up. If there's something wrong with integration, that's the good thing about it. I can just blame it on the new layer because I've had the previous layer and I've already checked it. Everything works fine. So chances are when I'm doing the integration, if the integration doesn't work, it's probably because of the new layer coming in. Not necessarily has to be the case. I mean, it could be that you've had a bug over here that you just didn't notice before. Okay, but it's just easier to blame what's new versus what was already existing. And the concept said, however, it's sometimes difficult to structure a system in such a clear-cut way. The types of architecture, control models, like say a centralized control. This is SE100 stuff. Okay, so we're gonna have a main function calling other sub functions, and then sub function calling, and then going back again to the main. So a tree structure going on. Okay, with a centralized command. Okay, we have an event-based control system. So a system that mainly sits idle in a particular state until something happens. So when it happens and while it's in a particular state, it's going to react in a certain way. Okay, and then it moves on to a different state after performing a particular functionality. So this is a typical centralized thing, you know, with the SE100 stuff, a main function called other ones. And also this is an event and message handler thing. So some event happens, it broadcasts to everything. Okay, everything that is registered with the broadcaster, RSS stuff, okay, subscriber stuff. Which is the premise behind what we call the observer design pattern, coming up at the end of the course. But before that, it's the premise behind the MVC, model view controller pattern architecture, okay, which is a major contribution of software engineering to the world of IT. Okay, everything depends on the MVC happening. Okay, and model means data, view presentation controls function. And if you just remember, just a moment ago, I was talking about this when I was talking about the layered architecture as well, right? And we'll see now how all of this tends to fit together. But again, MVC being a big concept to understand the software engineering. Now, really, it's one of those, it's really the most critical thing you need to know as a software engineer and a software engineering designer. Okay, once you get that, you get how to design software and how software applications, even at the enterprise level, should be. Okay, it's a guideline towards this. Otherwise, you're just chaotically and randomly doing stuff. Even if it works, it's just random chaotic stuff. Okay, so just gonna exit here for a second. That's actually the last slide of this. But I want to do something before I leave this chapter. I mean. Okay, so we have presentation. We have, oops, all right. Then we got the data. Okay. We already talked about the layered approach. Layer 0, pay attention to this, very, very careful. Layer 0, we said we're going to put the data in there, which is needed by the application. That'll be layer 1, which is needed by the presentation, which is layer 2. Okay. In the data layer, I could decide to use story architecture. Okay. I can use the MVC, which we haven't covered just yet. But the MVC, I'll make the M being my data, the view meaning my presentation, and my application is my control. We'll get to that next, not next chapter, but the chapter afterwards. Next chapter, we're going to be talking about the client server. And when talking about client server, a lot of times you'll see that the client is your website, is what you're actually seeing. Okay, and this here we have our client, whereas at the bottom we have our server. Sometimes the application itself has both the application and the presentation, whereas the server is just doing the data. But nonetheless, doesn't matter which way you have it. I'm just going to split it in the middle as such. Okay, whereas the top one would be your client. Yes. Oh, oh yeah. Sorry. Oh. It's funny because I didn't get any comments here. So guys, can you see it now? Can you just write down in the chat something? So I'm just going to repeat this again because all of this explanation just went for nothing. Okay, so guys, I was saying we begin with a process. You have application data, and then when we talked about the layered architecture, the data would be at the bottom. Okay, so we got layer 0 over here, and then we got layer 1 where it takes the application, and finally layer 2. So we have a layered architecture going on over here. So this is the layered. Okay, all of this is the layered. Okay, we can have the presentation and the application process at the client with the data at the server, or the application and the data at the server with the presentation, just the presentation being at the client, but we're having client server architecture happening over here. So that's another one. At the data level at the bottom, we can have the repository architecture set up at the bottom. Okay. And then finally, we'll have an MVC to hold it all together, which will be the topic of not the next chapter, but the chapter afterwards. Okay. Which gave rise to the main reason why we even have considered having the P and the A and the D split to begin with, and it's not a coincidence that the P is the V and the application is the control and the data is called the model. Just different name, but it's the same thing. Okay. And in other words, what I'm actually was just saying all of these architectures all together are happening at the same time. And you think, oh, this is fantasy land. No, this is not. This is actually happening everywhere. Okay. This is what's happening everywhere. This is why, you know, when you log in this morning from your phone, you'll see your class is something, but at night when you log in with your laptop, you're seeing the same thing. Okay. This from your home, you can from here or so on. When they got to create the enterprise architecture here at the university, you know, they thought about the data first. So there's a place where all the student data is there, all right, with your grades and the degrees and GPAs and everything there. And then above it is a little application thing that maybe calculates your transcripts and all that stuff. And then something at the presentation that shows your transcript, maybe in a PDF format or something like that. Okay, so can a system have more than one architecture at the same time? Yes. Matter of fact, this is quite commonly what actually happens. Okay, now the virtual architecture, okay, depending on the domain that you're dealing with, okay. What was the other one? The data flow architecture, again, if it happens to be the type of domain that you're in is more data centered, okay, kind of like factories, orange juice factories. This is what I like to think about data centers, really about the oranges and how they come in from the trucks from one end and they go in as packages from the other end. And it's all about the oranges and how they transform rather than the machines themselves. Okay. Yes. You have a question? Yeah, MVC, model view control. Okay, really model is data. So this one, let me just use a different color. I think I've used all of them. So the model is data, the view is presentation, and the control is application. Right? Tomato, tomato. Okay, this is just one community that created that, so they call it MVC. A different community called it PAD, but it's really the same exact thing. And they just happen to align rather beautifully with each other. And it's not by coincidence. It's not by absolute coincidence, okay? It's one of those tricky things now. I don't know if I should go into the next chapter. Let me see. Okay, client server architecture. Now let's. Yeah, all right, fine. We'll do it next lecture. And we'll do it on a clean slate. Okay, so that's it for today. Guys who are at home, I can see the chat now. Any questions about what we've covered in today's lecture? Let me just go back again to this one over here. Any questions about what we've covered in today's lecture? Okay, so next lecture is going to be client servers. Okay, some exercises on it. The lecture afterwards is going to be MVC and robustness analysis and all that stuff. Fun stuff. Difficult, very, very difficult. Robustness analysis is the most difficult thing in this course. Okay, but it's the most important thing you have to learn as a software engineer in your entire software engineering degree. That's the most, if you get one thing out of your degree, that's it. Okay, but it is the most difficult thing. Okay. All right, so thank you, everyone. I think nobody at home has any more questions, so we'll stop here, and I'll upload the slides, the video on YouTube at the end of the day. Okay. Take care.